Okay, friends, this is physics. This is today's lesson. Oops, yeah, I'm screen sharing. Okay, this is the first time I've taught you this way, posting a video. If you have questions, please comment on the post on Classroom. And as I scroll through this presentation, pause it if I'm talking over things you need to read without me yammering away, things like that. Okay, so there's your first note. It says share screen. Can you see this little thing in the corner on my screen? Let me just minimize it just to make sure. Okay, speed and velocity, the difference. Remember I touched on speed is magnitude. It's a scalar. It is not a vector the way velocity is. Velocity has a direction. So average speed, the total distance traveled divided by the total time taken to travel that distance, shown by this equation. Now remember that Family Circus cartoon I showed the difference between distance and displacement. Distance is the path traveled. Displacement is the straight line connection. This is speed. So speed goes with distance. Velocity goes with displacement. And in that equation that just came down, there's no vectors over velocity, or sorry, over the v, and there's nothing over the d. So these are scalars. T for time, delta t, change in time. There's no vector for time. Or is there? The delta, that's what the triangle in front of the t and the d is called. It's a change in, it's a Greek letter. Well, here we go. Average velocity, look at these old transitions. Average velocity, notice, has the arrow above it. I used a diagram instead of an average speed because I couldn't figure out on Keynote how to get the arrow above, and I've never tried since. This has been a few years. Anyways, average velocity is the total displacement, not distance now. Velocity goes with displacement. It's the total displacement or change in position divided by the total time for that displacement, shown by, check out the fancy transitions. And I drink water. All right, so this spacing looks like there's another point here. The slope of a position, don't you love that? The slope of a position time graph is velocity. If I hit this transition button too many times, it'll do it again. So I'm just gonna wait. You hear that gross sound in the background? That's one of my cats cleaning itself. The slope of a position time graph gives the velocity of an object. M, remember old school, y equals mx plus b, the equation of a line? That's what it's talking about, that slope. Y equals mx, the number that's multiplying the x. All right, moving along. See tutorial 1, speed, on page 14, and tutorial 2, velocity, on page 17 for examples. There's the note there that says, remember kilometers per hour need to be meters per second. Okay, let me, let's look at those tutorials, those examples. Stop sharing the screen. Okay, look, paper. Ironically, I was tutoring this kid last night and we were talking about slope-intercept form. So y equals mx plus b. M is the slope. Y equals 4x plus 1. 4 is the slope. 1 is the y-intercept. Anyways, I'm going to show the textbook tutorial 1 that I referenced. My screen looks funny. Still recording? Yeah, okay. I got myself a pencil ready to point with instead of my big stupid fingers. Okay, we'll zoom in a little bit. Granted, you guys will be, I was gonna say watching it on an iPad or something, but who knows? You might watch this on the screen in class tomorrow. Okay, so sample problem number 1, determining average speed. Your dog runs in a straight line. It doesn't matter the speed, but it's just saying this. In a straight line for a distance of 43 meters in 28 seconds. What's your dog's average speed? So the way this textbook works, it lists you the givens. It lists the required, so what you're looking for. Analysis is the way it's going to get there. And so this is the formula that we just learned. Speed is distance over time. So we're just plugging the numbers in. 43 divided by 28. This is what I would say in improv. It won't make sense to you right now probably, but it's just, you're just plugging and playing. I'll say that often. You're just throwing stuff into the formula. So your dog's average speed is 1.5 meters per second. You always need the units. It's speed, so there's no direction here. If there was a direction, you're talking velocity. So it's very important. And we'll get to that example in a second. Now it's just a different example. Instead of giving us the unknown of speed, like it did in the previous question, now we're just solving for D, for distance, the top one. Remember that question that we were going over a little bit from the last assignment, where you're isolating A, you're isolating T, you're learning that for, or reviewing that hopefully, for stuff like this. So anyways, you're given speed and time this time. So it's V equals D over T. You're going to multiply these two. Okay, V equals D over T. So they're just switching around. D equals V times T, right? Multiply both sides by T. 3.8 times 15, 57 meters in 15 seconds. Now, we need to solve for the displacement. It's interesting that they wrote this. That's not something you need to do. It doesn't hurt, but when you're writing the answer, 57 meters is what matters. All right, now I said I was gonna look at the speed. Oh yeah, and then there's velocity. Okay, this camera, that's a little wonky. Oh, that's beautiful. All right, so now we're getting in the vectors. Hey, so now we're talking velocity. So it says on a windy day, the position of a balloon changes as it is blown 82 meters north. Okay, now we're talking about displacement or position. Both have the vector and a direction. Away from a child in 15 seconds, so time is 15. What is the average velocity of the balloon? V is D over T. D is 82 meters north. Don't forget it. And T is 15 seconds. So 82 divided by 15, 5.5 meters per second north. That is the average velocity. Okay, average velocity, 5.5 meters per second, straight north. Second part is just, now this is why I had the little note about make sure you change kilometers per second to meters per second, because it comes up in this question, if I can get this right. This is page 18, if this isn't super clear for you. A subway train travels at an average velocity of 22.3 kilometers per hour west. Okay, velocity, so we have a direction. We're gonna have to change that to meters per second. How long will it take? So what is the time? What is T for the subway train to undergo a displacement of 241 meters west? Now, the interesting thing here, if you're like me, you'll find it interesting. We have displacement, V equals D over T, right? Where is it that I want to show it to? So this is converting it. I'll talk about that in 1 second. But V equals D over T. Now it's switched the T and the V, right? So T equals D over V. We have these units, displacement, west, velocity, west. Those cancel. That's why time has the unit of seconds. And also the meters here cancel. The seconds is left over. And that's why it works out that way. Just thought I'd mention it. Notice it says here we have to convert to metric units. So we got to do 22.3 kilometers an hour to meters per second. Now it shows it here. It's a little bit of a funny way. So I'm going to leave that there because it's there. I'm not going to talk about it. You can go there if you want. But I'm going to show you what I always do and I always think of. And so maybe this will help you remember versus memorize. So let's just say, what was it? 22.3 or something? Yeah. Okay. So 22.3 kilometers per hour. Oh, that's just pops, eh? That black? I think that's a new marker. Now this kilometers per hour is like saying 22.3 kilometers over 1 hour. What in the world is this? HR over 1 hour. So kilometers per hour, think of it this way, kilometers is 1,000 meters. 1 hour is 60 minutes times 60 seconds. So it's 1,000 over 3,600 kilometers per hour. So 22.3 would be 22.3 times 1,000 divided by 3,600. I don't have a regular, oh, I do have a calculator. Now what the textbook is showing is the same way. I wanted to kind of explain it, how I kind of think of it. So 22.3 times 1,000, 22,300 divided by 3,600, 6.19. What did the textbook have? 6.1944, yeah, it kept a lot of decimals. Okay, hopefully that makes sense. Hopefully I don't have to record many videos like this. It's really hard when I don't have the instant feedback from you guys. Okay, let's go back to the notes. Yeah, you know what? I really like presenting, but it's probably just easier for you guys to read it this way. Oh, there's one more page. Let's do this. I'm gonna have a drink of water. Okay, you can pause it if you need to write this stuff down in silence. Motion with uniform velocity is the motion of an object at a constant speed in a straight line. Uniform velocity, uniform meaning not changing, so it's a constant speed. And if it were to change direction, that still counts as a change. So it's constant speed, constant direction, so uniform velocity. If we were to graph it in a position time graph, time is along the bottom, time is the independent variable. The slope, oh, yeah, we'll get to that because I didn't say it right there, but it has a straight line. We'll talk about well, I'll just tell you, the slope is the velocity. Position time graph, the slope is the velocity. Motion with non-uniform velocity or accelerated motion. Accelerated, we think, you know, acceleration is speeding up. We don't use the term deceleration in physics. It's negative acceleration. So if my speed starts at 40 and goes to 20, I have accelerated, but I've accelerated in the reverse direction. We'll have lots of time to talk about this, and I can show you physically. I'm doing it right now, but you can't see me. Anyways, if that's giving you grief, we'll talk about it. Anything that is giving you grief, we will talk about. So it says examples of the table of the above are in table 1 on page 18. So might as well have a look at that. There's this table at the bottom, page 18. So it says a car travels down a straight highway, so it's not changing the direction at all, at a steady 100 kilometers an hour. Steady, it's trying to be clever, but nothing's changing. The direction is not changing, and neither is the speed. That's uniform velocity. Constant speed in a straight line. Passenger on an amusement park ride travels in a circle. Okay, so if you're in a circle, and we're gonna talk a lot about this. I think it's grade 12 as well. The direction is constantly changing. Every moment it is going, like if you think of kind of drawing tangents around it. I don't know if you can see that at all, what I'm doing. It is constantly, like that's the arrow that it's going in, it is constantly changing direction. So who cares what the speed is? Constant speed, great. The direction is forever changing. Passenger is traveling at a constant speed, but not in a straight line. She is traveling in a circle. It's a she. I didn't catch that part. Last one, a parachutist jumps out of an aircraft. I don't know that they use those words, but they jump out of an aircraft. So this is interesting because after the parachute opens, that's when you're dropping at a constant speed. It's also kind of assuming there's no side wind or anything. Non-uniform velocity is before the parachute opens because you're accelerating towards the earth. You're plummeting. I've done this. I have a funny story about it if you ever want to hear. So before this one's a dude. I don't know. Before he opens the parachute, the speed of the parachutist will increase due to gravity, right? It's accelerating. Once the parachute is open, the speed will become constant due to air resistance. He will then fall at a constant speed in the same direction. So like I said, downwards, you could spiral, you could move around. So it has to be the same exact direction. Now I know the notes are going to reference this table over here, so I'm just going to go to it and then we'll get the notes on it after. So this is section, how can I do it? Oh yeah, that's better. Interpreting position time graphs. So before, when I referenced a position time graph, time's on the bottom, it's the independent variable. This is the position. The position at whatever it is, this looks like a 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. The position does not change over time. The object is at rest. Okay, horizontal straight line, the slope is 0. The object has a velocity of 0. That is a constant velocity. The object is at rest. The object is at a constant positive position relative to the reference position. And you decide what's positive. You might decide that, like, if we do this, like this is left, this is, no, this is right. What is wrong with me? And this is left, you know, kind of up and down. Generally speaking, we take the up to be positive and the right to be positive. I always have a mental block when I'm doing west and east because I always think of west as positive and I don't know why. So anyways, you kind of decide, oh, the ball's to the right of the dude. Okay, so then it's positive. If the ball is to the left, negative. That position is relative. The position of the ball is relative to this person. Okay, everything's the exact same. It's kind of like the number line we're going to talk about next unit in math. It's just kind of opposite. You can see the ball's a little bit closer here. That's why it's closer there as opposed to there. Man, I wish we were doing this in person because I feel like there might be questions. So everything's the same. Horizontal straight line. The slope is 0. It has a velocity of 0. That's because the object is at rest. The object is at a constant negative position relative to the reference position. The object is stationary at a location to the west of the reference position. Or west is negative as well. Don't write in your textbook. Graph C. Now, I'm going to do this so you don't read and maybe you're looking at your own, but just look at the graph. See what you can figure out just from the graph and not the explanation. Okay, the position is changing, right? It's constantly changing at the exact same rate. It's constantly changing. It is getting further away, right? Because the distance is increasing over time. So it is getting further away in a positive direction. Right? It's not going downwards like this. It doesn't have a negative slope. It has a positive slope. So the graph is a straight line with a positive slope. Straight lines with non-zero slopes are always represent a constant non-zero velocity. Okay, so it's a constant uniform velocity. From the y-axis, vertical axis, we know the object is moving eastward. See the E, because it gives the direction. These are all E. Oh, by the way, this one here, when it was negative, the east, remember, because east is over here, west is over here, so this is negative east. That's why we can use this. If this said W here, the line would be up here. Holy moly, I hope this is making sense. Okay, from here, since the graph, oops, I jumped a spot, sorry, this is where we were. We know the object is moving eastward. The object's velocity can be determined from the slope, right? Rise over run. You take whatever this difference is, divide it by this, rise over run. Look, it's running. Graph D. This is funny to me for some reason. I don't need to read every single thing to you. Hopefully you're picking up on it. It's changing direction, negative slope. It's constant speed, which is different from constant acceleration. All right. This feels like one of those memes when they make fun of someone's name and they just change weird things. It's like Troy Westwood, Troy Eastwood, whatever. All right, let's get back to notes. How do I do this? Examples of the above are in table 1, page 18. That's the one where we looked, where that was like straight highway, amusement park ride, and parachutist. Position time graphs, table 2, that's what we just looked at. That's your assignment. That looks like it. Next time I hit the button, it's probably gonna change the slide, but I'm gonna do it anyway because I need to find out. So you can pause or whatever. Anyways, do 1, not 2, don't worry about that. Do 3 to 8. One of the questions says copy the chart. You don't have to copy the chart. Yeah, that's it. Okay. Hopefully that makes sense. If you have questions, please post it kind of as a comment under this post, and I will more than likely video you a response soon. Anyways, thank you. Bye-bye.